Hello everyone, my name is Kirill Puzankov, and today I'm going to present on some comprehensive hacker techniques in mobile networks that we made during our security monitoring projects and the security assessment project. So I work at Positive Technologies, and we work with mobile operators, helping them to protect. So it's security assessments and security monitoring projects that just are getting the information about what attacks are going on in the real world. So, like being a vendor, we created a telecom attack discovery product just to help the operators to get the information on from where they are being attacked. So, actually, the SS7, that is the protocol, that is the mobile telecommunications were built from, and it has a lot of insecurity because it was developed in the 70s where nobody cared about security because it was a closed network and only PSTN, only landline operators had the access to it. And when the mobile networks started developing, it was like start of the 21st century, and the stack of protocol, Cictron, was developed, and it really became a big problem. So our team has showed the world as how it is easy to compromise Facebook accounts, WhatsApp, Telegrams, and whatever, just with the method of interception of the SMS message. And after that, again, we did a research. Is it possible to get the access to the CryptoCoin wallet? And again, the method worked. And actually, no one cared. No any operator cared about this problem. They know there are, but it wasn't just concerning the money. So the operator doesn't lose the money, he doesn't care. And in 2017, in May, the large operator had to admit that she had a two-step attack, and the hackers, first of all, they were able to get the malware to smartphones of the users and laptops, and so this way to get their login accounts. And after that, having the access to the SS7 network, they were able to intercept one-time password codes for the transactions, and for the victims at night, not to be able to read that something's going on. So they just transferred a really big amount of money, and after that, the operators really started to care. So, as I told, the SS7 networks were developed in the 20th century. It was in 1970s, and no one cared about security. And with the developing of mobile telecommunication in 21st century, there were mobile networks starting to appear. A lot of virtual operator, WAS providers, value-added services. And the Cictron, the protocol, the SS7 over IP was developed, and when you have something over IP, it's no longer secure. So, and all the vulnerabilities that were in the SS7, they came to the Cictron over IP. So, and being accessible to anyone. One of the main problems that you even with the operators having like newer networks like LTE, 4G, actually they have the same vulnerabilities. But even if the operators only 4G, it just have to support the SS7 for the roaming interconnection, and that roaming interconnection is really big problem because like for the malefactor, if it has like an access through the SS7 Cictron, he can reach any network through any protocol for the roaming purposes, So you just have to get the access over the SS7, and that's going to be enough. So how the operators started care? So they started to implement different solutions. So it's like an SMS home routing. We'll explore this thing later. Like security configuration of the devices, started implementing the SS7 firewalls, security monitoring, and so on. And of course, like the most advanced, they started to perform security assessment. That's really important to know if your network is being really vulnerable, just to know it by having an expert trying to pen test it. And during security assessment is often coupled with security monitoring projects just to get the information if the network is really being attacked by the real world. So before I go to the techniques that techniques that allow to bypass security measures, I just need to explain something about the basic nodes and identifiers that I used in mobile networks. So the first is MSISDN, that's Mobile Subscriber Integrated Services Digital Number. So that's just like a normal number that we are used to. Okay, give you my number, and that's like MSISDN. So every MSISDN, every number, is strictly connected to another identity, that's IMSI, International Mobile Subscriber Identity. So actually, the normal person does not know his IMSI, but this identity is used just for the mobile networks to connect to the stations and so on. So it's just operator equipment. The STP, that signaling transfer point, that's the node just very often set on the border of the network, and it just receives all the external traffic coming from another operator. So the HLR, home location register, that's a node that contains a database of home subscribers, of home operator subscribers. And the next node is MSCVLR. So that's just basically like two nodes that are very often put in just one equipment. So that's mobile switching center alongside with a visitor location register. So the visitor location register, that's a database that contains information about subscriber profiles that is currently being served by this commutator. So, and it's not only home subscribers, it can be visiting subscribers from other networks. And the MSC is the commutator that provides access to the SMS messages, while VLR processes more of voice communications. So, and the SMSC, that's just SMS sensors that is used for message delivery. Then we go to our first attack, that is SMS home routing bypass. So, first of all, I would like just to tell how is the normal SMS delivery is going without the SMS home routing decision in place. So, the external SMS sender sends SRI for a SAM message, just send routing for a SAM. He just basically asking, I have a message for your subscriber, just tell me what commutator he's being served by, and what is his IMSI identifier, just to properly route the message. And the STP routes this message to the HLR, to the database, and that database have all the information about the IMSI identifier and the MSC address that's being served by for the subscriber. So actually, that in this way, the external SMS sender gets the information, real IMSI identifier and the MSC address, and this information can be used for like more complicated attacks. Just the main thing in telco networks is just to get the IMSI identifier of the subscriber. So you like everyone knows the number, but no one knows the IMSI identifier. So that's how it is performed in operating network without SMS home routing decision in place. After that, the external SMS sender sends empty SMS message using that real MSI identifier and with SMS text, and the message is being delivered to the MSC and then up to the subscriber. So when the SMS home routing decision is in place, how does the process go? So again, external SMS sender sends SRI for some message addressed by MSISDN, just the mobile number, and the STP routes this message not to the HLR, but to the SMS router. That's just a special device that is put in operating networks. And that SMS router, he actually creates a correlation between a real IMSI identifier and a fake. And he's not replying with real MSC that is serving the subscriber. He just replying with his own address, often, really often. So, and the external SMS sender now gets fake IMSI identifier and the SMS router address instead of the MSC commutator. So, and if that external SMS sender would have been like a malefactor, he's not going to be able to perform further attacks because he has fake addresses. So, and after that, the empty SMS message comes to the STP, and the STP again transfers this message to the SMS router with that fake identifiers. So that's actually the first step of the SMS delivery with the SMS home routing in place. And after that, the SMS router initiates a SRI for SAM procedure to the HLR, and actually the HLR replies with real addresses, but it is inside the operator network, so it's okay, it's not going to be disclosed. And the SMS router does the SMS delivery procedure. And that's the second step. So how it does work against hackers. So the hacker sends SRI for some message, just trying to obtain IMSI identifier of the subscriber and the MSC address, and the message goes to the SMS router, and SMS router replies with fake data. So after I go right to the attack, I just have to go and explain something about numbering plans. So there are some numbering plans that are used in telecom networks. So the first one is E.164. So that's a numbering plane that is used for MSISDN. We've already explored it before. And a GT. GT is like the same number, the same mobile number, but that is used for network equipment. So it has the same format. So like it consists of country code. So for India, it's 91 country code and network destination code. So here, for example, I took just 1, 2, 3, 4. So it just contains for India of 4 digits that just get you the network code, and the rest digits are like mobile identity. So it's like the rest changing part of the number, the mobile number. And we have another numbering plan, E.212. That's for IMSI identity. It consists of mobile country code and mobile network code. So that's not like country code and network destination code. That's like the codes that are, again, mapped to that E.164 numbering plan, but they're not the same. So for India, we have, I guess, 2 mobile country codes. That's 404 or 405. So I use just the first code that was used as 404, for example. And mobile network code, just I took here, for example, 99. So, and the rest, again, the part that identifies a subscriber. So, and we also have the third numbering plan that is E.214. That consists of country code, network destination code, and the rest part is taken from the IMSI identity. So actually, this numbering plan is used like for update location messages and just for the operator to be able to get from where the request came. So as you can see there, the first part of The number is the operator part, so like the network equipment knows where to route. And after the operator gets it on its STP, based on that, the rest part of the number, he just realized to what database, the HLR, to route the message. Okay, so like every body device, the STP has a routing table, and it has some rules like where to route. So when the external SS7 message comes, he just the STP explores the message and decides how to proceed. So when he sees the numbering plan like E.214, he just decides. He just processed the message to another like a global title translation table, and he just decides to what HLR it should route the message. So actually, normally, the SRI4SM message is just used being addressed in E164 numbering plan. And when the SMS router, SMS home routing decisions are in place, so when they see like an E.164 numbering plan and opcode SRI4SM code of operation, they just transmit the message to the SMS router. And if the STP routing table is not being designed or configured good, the STP can just first look at the E.214 numbering plan and just route it directly to the HLR. So as you can see, the MSISDN should be actually in a normal packet. It should be given in on map level and on SCCP, signaling connection control part level. So and like how this attack actually works. So the malefactor using that E214 numbering plan and just having a random IMSI identifier and addressed by MSISDN, the message go to the STP. The STP looks like its numbering plan E214. He just don't care that SRI4SM, and he will not forward the message to the SMS router, and the message goes right to the HLR. And the HLR actually replies with real information. So it gets like real MSI identifier, a real MSC address that is being served, that is serving the subscriber. Okay. So and how it should be? How should be prevented? So the STP routing table should be modified and just concern like first of all the code of operation. So if it's SRI4SM, no matter what numbering plan is used, you should just route the message to the SMS router, not right to the HLR. And the SMS router will reply with fake data. So, and we have another type of SMS home routing bypass attack that we're going to explore now. So, during one of the security monitoring projects, we came across this situation. So, we have an operator headquarters and the regional operator. So, the malefactor just tries to get that IMSI identifier from the regional operator. So, he sends SRI4SM message addressed by MSISDN. The STP receives this message. He transfers it to the SMS router. SMS router replies with fake data, so and the SMS router address, so everything works fine. But during some investigation, the malefactor then just sent this message to the headquarters STP headquarters, and that's been addressed by the HLR, the database GT, and the packet consists has an MSISDN number for the subscriber. So the STP of the headquarters received this message, and he's like, no, it's not for me, but it's for the regional operator. So he just retransmits the message to the STP, of the regional operator. And that STP just perceived this message as trusted because it came from the operator headquarters, and he just transmit this message exactly to the HLR. And of course, the HLR replies to the mail vector with real data. So it's an SRI4SM message containing real IMSI identifier and the MSC address that the subscriber is being served by. So how to prevent this situation? So of course, as a first step, you should fix routing from the headquarters STP and like child's network, because all external SRI4SM messages should be routed to an SMS router, no matter what. And actually, this type of situation can rise after some hardware or software updates in the networks. And that's why security assessment and vulnerability management is an important part of security process. So the next attack, it's positioning enhancement. So at any time, the subscriber is being served only by one cell station, but base station, sorry. But the mobile device is just listening to a lot of base stations that is under radio coverage. So, and like if you are able to get all the base stations that the mobile network sees, you can just refine the position, the location of the subscriber. So, and then when you just perform like a location discovery attacks using like the provide subscriber info message, you just only get the one cell ID that is currently serving the cell that is used by a base station, just only one. And during one of our security monitoring projects, we just came across a strange situation. So here you can see the during 4 hours, we have like a lot of attacks on one exact subscriber, and it's unstructured SS notify that were not performed properly because that was an abort coming, and these attacks came from different countries, you know, that you can see on the map. And so we investigated it, and we got, like here we have a 3-minute interval on the timeline, and we noticed a really strange thing. So it's provide subscriber info, that's a message that is used for location discovery. And after that, it goes unstructured SS notify aborted attack. And again, it comes, the triple comes with the provide subscriber info completed procedure. So we were really interested, and we just decided to recreate the position refinement attack. So as a first step, we just make a provide subscriber info procedure to get the cell ID that is currently serving the subscriber. So we got, it's like ODFB. As a second step, we just perform that unstructured SS notify, and we, as you can see, we put the USSD string missing. So it's like a silent USSD message for the subscriber not to be able to just get that he's being hacked or something. And as you can see, the Wireshark just perceived this packet as a malformed. But what's going on in the real world? The MSC VLR actually processes. So she proceeds that procedure, and she just sends paging request to the base station. And to get some cell IDs, identifiers from the base station. And the base station just responds with the paging response containing cell ID identifier. And it just gets a return error with the local value unknown alphabet. So it's like a malformed packet. The equipment cannot proceed it properly, But actually, the MSC VLR, while it should just send right away an abort message, it just touches the radio access network. So here I'll just omit some messages on the radio access network interface on A interface, and it just touches the radio access network and sends return raw message back to the MSC VLR, and it transfers it to the requesting network. So actually, it would have really been better if the MSC VLR just aborted the operation, just not touching the radio access network equipment. And actually, after this, we send another provide subscriber info request, and we get another cell ID. So having that cell IDs in place, we just put it on the map, and as you can see, so we have two red circles. That's just a radio access coverage of that base station that we get information on, and just the green circle is the most the coverage of the subscriber area, and like the green point is the most probable position of the subscriber. So having several cell IDs in place, you can refine the subscriber location properly. So, and as I already said, the Wireshark treats this packet as a malformed while the equipment proceeds the operation. So fixing this problem in the network equipment can just take really a lot of time, because it's a really long and difficult process. So, and there are actually means to block these messages, because either provide subscriber info message or unstructured SS notify message, they are just treated as a category 2 messages in accordance and with GSMA FASC IR82 standard, and you just need to block this category 2 illegal messages using any possible means. So it can be like fixing on the side of the equipment, or just implementing some firewalls and so on. So, and I guess the last attack for today, it's firewall bypass. So, how the SS7 firewall works against hackers in the operating network. So, here comes the update location message. So it's like a subscriber arriving to a new operating network, and this message contains 3 identifiers. So it's IMSI identifier. That's for I took the same Indian subscriber we explored the previous slides. It has the MSC and the VLR address that are very often the same, because the MSC and VLR are really often sit in one node. So, and it's just the addresses of the requesting node, as it should be in real life. And the SS7 firewall get this message, and it just it has a table, like a location table, that consists of IMSI identifiers, like VLR address, and last time the update location came. So if this update location just new, like the firewall didn't have any update location on that particular subscriber, it just creates a record containing the IMSI identifier, VLR address, and the time. So, and after that, if another update location comes, like it's I guess it's 11 o'clock, and again it contains the IMSI identifier, MSC, and VLR address, but already from another country. So 49 code was from Germany, and the 261, that's from Madagascar, and the SS7 firewall just explores this message, and he gets the country code from the VLR and just puts it to another table that is a velocity table. So it just checks, is it possible to travel between the given period for a subscriber? It just has the numbers for like traveling all over the world. So it's like from Germany to Germany, velocity is 0. So every update location is processed, even if it's fake, even if it's fake registration. But from Germany to Madagascar, the minimum time interval, as you can see, like 8 hours. And he compares the numbers. So he gets 49 from the previous table, and he gets 261 from that request coming just in 1 hour difference. So he calculates 1 hour. 1 hour is just less than 8 hours, and he just logs this. So that's how it works. And as you can see, the MSC address is never used for the table, for that exact firewall. So, and what you can do with this? So the hacker sends a request that has an MSC address, that is his fake address, Madagascar, and he puts the VLR of, or like a real VLR, like German. And the firewall just treats the message, just get the code from the VLR. So it's 49 from the request. So it's velocity 0. Velocity is 0, and the time difference is just 1 hour. So he just proceeds the message, you know. So he says it's okay. And what's actually going on from the subscriber view here? So the update location comes, and the equipment proceeds the operation, and the HLR updates its database containing this MSC and VLR identifier. So the MSC is just the hacker one that he owns, and the VLR is the real one. So, and from a subscriber view, like all the voice calls, they're working through a real equipment, while the SMS messages, like the MTSM's messages, they come to the fake MSC of the hacker. So, like while the voice calls cannot be intercepted in this way, all the SMS messages with one-time passwords and so on can be intercepted. So, decision is pretty clear. The SS7 firewall must check both the VLR and the MSC addresses in all incoming update location messages, just to prevent this situation. So, as our research showed, just having a security tool in place is just not enough. And the security is just not about the number of tools, it's just a process. So you have to approach it really in a process way. So we should take best practice from IP security in terms of configuring network devices, like using standards and so on. So actually in the operating networks, there are a lot of configuration mistakes and so on. And security assessment, vulnerability management, security monitoring, that's just a really, really good part of the security process in telecom networks. So I guess that's it. Your questions?
Any question? Yeah. How the STP routing table works and how they get the numbers and they calculate the numbers.
Sorry?
STP routing tables.
STP routing table?
Yes, yes.
So it contains the information about the subscriber. So it has a routing table. So whenever he gets a message, he just explores it, and based on certain parts of the message, he just transmits to the appropriate HLR. So like the message that is routed in E.214 numbering plan, it contains the operator part, that is country code, and network destination code. So Uh, and the rest part is like an identity of subscriber. And the STP has an information about all the subscribers and which subscriber belong to which HLR. So he just she just gets this chunk and routes to the appropriate HLR.
Can we spoof STP routing table?
Uh, well, compromise equipment is actually comparing to the SS7 vulnerability, it would be much difficult, more difficult than just getting access to the SS7 networks and perform attacks. Because yeah, you may, but it's gonna be just difficult. There are a lot of vulnerabilities in the SS7 networks you just can explore, and you know, you just can get access like for not much money, amount of money. So I think it's the easiest way. Yeah.
Thanks.
So all of the mentioned attacks works on SS7, right?
Yeah.
So an attacker needs to have SS7 access in order to launch these attacks.
Yeah. Yeah.
So I wanted to know how easy it is for a common man to get SS7 access.
Okay, I got you. That's a good question. You know, like 3 years we explored this situation and we just contacted some third world operators in Asia or Africa. I can't even recall, you know. And we were able to get the really literally contract side. We just didn't continue for like $3,000 per month. So that's not such a big amount of money. And actually, in I guess November of last year, the company, I cannot really remember the name. They had the same experiment, but with the operator in Europe, and they were just asked for like 10K. So I guess 3 years ago it was a little bit cheaper, yeah, but it's just a matter of money, and you just can use any operator with Lex laws just to get there.
Thank you.
Any more questions? Wow. So this brings to the end of this talk. So give him a big round of applause because this was a great research.